Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have an Harman Kardon HK450 DC amplifier receiver. These are nice units. I like a lot of what's going on with this. The build quality is good. They have a great sound when they're working and they're tuned up, and they kind of look. I like the looks of them too, with the backlit dial scale and the clean look of the front behind the glass. And yeah, so this is I picked this one up. I'm gonna flip it, and I think it has a problem. So let's have a look inside and I'll show you what I found so far. So I had the lid off just so that I could blow the dust out with compressed air, and I noticed something that's critical for its operation. We're going to have a look here as soon as I get this lid off, and it should be an easy fix. I am hoping it is. It's quite dirty. Oh, that was weird. A little bit of a rust stain here. I think it had a spill on it or something. I don't know what that's all about. Alright, so have a look down here. Nasty damage. That resistor completely blew it up. That is, what resistor is this? That's 449 here. This is 450 here. Now that's a 100 ohm resistor, according to the other channel down here. You see there's a 100 ohm resistor. So what does this resistor do? Let's have a look. You can see it here. Now I have a feeling these two devices are either blown or shorted. That would be the cause of what's going on here. I don't see any damage down here with the drivers or anything else. But have a look at this. Somebody replaced caps in this thing. They put some fine gold Nichicons in a few spots. This is all new caps. That's a new cap, a Jamicon. Not a quality cap, but it's been replaced. This one's new. There's a few down here. You can see they're gold Nichicons. So somebody's been playing around here. Fuses are intact, it looks like. So the power supply is working. And look at this spider in here already. And I thought I blew this out with compressed air. Okay, here we're looking at the left channel power amplifier. And right here is our resistor R450, 100 ohm resistor, half watt. And it's directly between the two emitters of HK418, 420. So to blow this resistor up, you'd have to have rail voltages across it, and I have a feeling one or both of these transistors are blown up, or it could be one or both of these output devices blown up. So we're going to have to do some testing around here to see what's going on, and we'll also have to test back farther, make sure that these transistors are okay, because typically anytime you blow up the outputs on an amplifier, you get voltages and currents that go back earlier in the circuit and do damage. So you want to make sure that anything that's connected to these parts here are free from damage. That would include any resistor, diodes, capacitors. So we're going to go through and check these four to start. Check this resistor. I think it's open. If it's had, what's the B plus on this thing? Okay, B plus B minus is plus or minus 32 volts. So we have 64 volts that could have went across that resistor if we had a full short on the fault, and that would be catastrophic for anything in the way of that. So let's go have a look. Okay, so let's see if we can find here. This one is, let's see, that one's dead short. And that's dead short. So, no, it's not dead short. That is open. Reading across the capacitor. Is this one dead short too? Sometimes you have your reading. Yeah, I think that is a dead short. It might read 000 as a dead short, but then you might be reading across one of the main filter caps. Let's try this side. This side is shorted as well. That's not a healthy number. Nor is that. Yeah, both these transistors are pooched, I think, the batwing transistors. So they're both damaged. Now, where's our driver? What did I say, 418 and 420? Where is 418? 418 is here. 420 is here. Looks like, okay, let's see this one. I can see a crack on this one. There's a crack on one of the leads of this transistor. I think it's 420. So let's see what this says. It's not shorted, which is a good sign. However, it might be damaged because it's not reading the correct voltage drop. And the other one is here. That's a good number. That's a good number. That's a dead short. Collector to emitter short. Yeah. This one here. That's not good. So it looks like we got 3, possibly 4 dead transistors. What's this resistor measure? It's probably fully open. Yeah, it's reading open. Mega ohms. So 3 dead transistors, 1 dead resistor, and possibly a 4th dead transistor. Let's replace these and see if we can get this running before we do anything else. It's like somebody's been replacing caps in this thing. I don't see any butchered soldering jobs. Looks all okay. But I'll have to inspect everything. Since this one here was cracked, that could have been the cause of the catastrophic event. Right here, this joint is cracked. Alright, let's pull these transistors out. And I don't have batwing transistors, but I do have replacements that I made. And I think I'll pull them out and I'll show you what they are. Another thing we're going to have to do is check this biasing transistor. It looks like it got cooked, but I think it just got collateral damage. Alright, so let's go through some of these transistors. These are the drivers. This one here is a 2SB647, and I think the other one's a 2SD666 or something, 668 or something like that. Very common. Let's see what this says. Not looking good. Nope. Let me reset my connections and try again. Nope. This one here had a thermal tracking diode attached to it. That's why it has a heatsink compound. This is a 2SD667, and it's probably bad as well. Yeah, it's not looking good for this one either. Alright. 2SD587A. Let's see how this one looks. Expecting it to be dead. Yep. USB 617. Goner. 4 dead transistors and 1 dead resistor. Alright, I'm going to go through the circuit with a diode check meter, and I'm going to check the remainder transistors in this side of the circuit here, in this left channel. I'm going to make sure they're all good. Plus there's a couple diodes. This diode here, this thermal tracker. And there is a transistor here. This is the biasing transistor. I want to check that one as well. And make sure everything's good on this side before I start loading it with new parts. Just applying power to the lamps here. I do this as a test. What you do is you pull the fuse out from the transformer, and then you can apply power, because if you don't, you backfeed power into the transformer, you blow the fuse. But somebody replaced these lamps with LEDs, warm white LEDs, so it looks pretty good. I think I'm going to leave that alone. And they're all working and present, so this is a little better than I expected. Just needs cleaning. Okay, these are the bias transistors. These are 2SC1472s. And believe it or not, they're Darlingtons, so let's try them out. They should read very high HFE. See what we got. If they don't read very good, okay, 1.84K. Let's check the other one. Might not be beneficial to change them, I don't know. 2.67K. Alright, so this one might be bad. I don't know. I have to look at the data sheet, see what the minimum HFE is for this transistor. We might go ahead and replace both of these. I pulled out these caps. These are the original Elna's 4700 microfarad. They measure down around 4,000 each one. I think one of them measures 39. I'm going to replace these with 6800 microfarad. I have some here, so I'll just pop them in. Just going through and replacing these caps underneath here, under these by these tone controls. They're really hard to get to, so remove everything and then you get access. But then the caps I'm pulling out are garbage, so this is a good thing. I wanted to take the front faceplate off to fix this. You can see that. It's got a crinkle in it. So I want to see if I can get this plate off. It's very thin, and but the glue is letting go, so I'm hopeful I can just massage this off of the plastic base and then do the body work here, clean and fix this up, straighten whatever I need to, and then I can just glue it back on. But I think somebody glued this once already. I'm not sure. Okay, I'm going to be taking these transistors out and repasting the compound because it's all dried up and hard. So I'll take these out and redo that. I have selected my new transistors. Oh boy, this is what I don't like about this amplifier. You can't get your hand in here. It's even hard to get tools in. But I don't understand why Harman Kardon used these batwing transistors. These are not really suitable for this job. This is a low power amplifier. I think it tops out at 35 watts. I can't remember. But these are pretty stout transistors. These are good for I think 80 watts. And the voltage rating on these is high too. So they have, well, the reason they have such good rating is because they have such good heat sinking. They have, the transistor body is mounted on this copper plate, and yeah, look how dry that is. It's all falling apart. Replace all this. But yeah, I don't understand why Harman Kardon used these transistors. They could have done something with a lighter duty transistor, and it would work just as fine. So my plan is to use these. These are my substitute. These are ST transistors. These are the D45H11, D44H11, the complementary pair. And these have the same current rating, I think. Not quite as high as voltage rating, but this doesn't need a high voltage rating. And now that I soldered them to a copper plate, they have a higher wattage rating. That's why I use them. So we'll get these pasted up and put in, and I'll get this cleaned up and put in, and then we'll be able to fire this thing up for the first time and see how it sounds. Still have to do all this. I'm cleaning switches, replacing caps. I want to recap the tuner. I found bad caps in the preamp section and the tone controls. They were failed caps here, so I'm expecting to find failed caps in the tuner as well. The caps I'm talking about are these blue Mashishita caps. They have, well, not this one. Where's the one that's failed? A couple here that failed. They had green legs, and the ESRs, a 10 microfarad cap, I measured like 3 microfarad, 75 ohm ESR, so that's failed. So I'm going to replace all the rest of these caps. There's some more down here, these blue Meshishitas, and then there's these bloody TK caps I hate. So I'll get all those out. The ones that the previous tech did, replaced these green Nichicons, they can stay. I have a feeling they're still good. So we'll clean all this up, and then it won't be long before I'll get this thing fired up. Just want to talk a bit about these printed circuit boards that Harman Kardon uses. They're pretty poor quality for what they are. They should have had a higher quality board. Some of these pads are so tiny, and there's like a little tiny ring of copper around that hole. The holes are kind of oversized. Well, they're probably sized right, but the pads are too small. So you have that, and then you get nothing for the solder to connect to, really. It's just, it kind of hangs up in the air. And then these pads lift very easy, so you got to be careful. And another thing with when you have a pad that's got really no surface area is you get cracked solder joints a lot easier. So there was a bodge here, and I took it out and added a 10 ohm chip resistor just to clean up the board a bit. There is one defect I'm going to show you here. I don't know if you can see this here. This is, let me stick my hand under. This is a capacitor that the previous tech soldered in. So this is the star ground, and then this is your input for left or right channel, I can't remember. And then there's a coupling capacitor right here. And if I, where is it? Yeah, you can wiggle it around, it's moving. It was moving. I think the rosin flux is holding it now. I'm surprised that worked. So I'll 3-solder that. I'm looking at the star ground arrangement. I think I might change it. This is the transformer leads, comes in to the board, goes to the 2 fuses, and then it goes to the rectifiers and the capacitors. This is the center tap for the transformer. Comes on the board, runs left and right to both capacitor banks, and then they tap off here. They have black wire that runs around to the star ground. Same on this side. The black wire runs around to the star ground. I think I might just take this and move it here and eliminate this, and then these wires can stay because these capacitors still need to have a ground reference, but this wasn't laid out very good. I think this is all ground here, but it doesn't break through to here. Yeah, I think I might do that. I don't know if it's going to make any difference in background hum or not. I'll try it and see if it screws up. I might just move right back. And there are some cracked solders around this transistor. They're not fully cracked, but I can see the rings. I'll have to resolder all this. Okay, I've been looking at this yesterday, and then I had to think about it last night. What I did is I pulled out Bob Cordell's book on amplifier design, and I was doing some reading last night, and specifically about ground loops and star grounding. This thing is a mess as far as grounding is concerned. I can see just from here, I see 3, maybe possibly 5 ground loops that are wired here. We have this wire here. Well, first of all, we have the left and right speaker grounds are tied together, and they should actually be independent of each other because we have 2 different power supplies here. We have a left and a right power supply, even though they're fed from the same transformer. Once it gets rectified, filtered, it's considered an independent supply from the capacitors, because the capacitors is your ground zero kind of your power supply. That's your low impedance path. And all of your current grounds should be separate from your signal grounds, and your current grounds and signal grounds should reference back to your ground zero, which is your filter capacitors. But this thing is just, no, it is not set up that way. I don't know what they were thinking. So, like I said, left and right channel, the grounds are tied together, even though they have system 1 and system 2 grounds tied together, left and right tied together, left and right tied together. So they're all combined onto one wire, and then this wire runs back to this ground here. But that's not all. They have from system 1, system 2, they have a ground wire running back to the power supply here, and another wire running back to the power supply here. So there's essentially 3 wires between all these grounds. So they're all interconnected, and this is all one big ground loop. Also, we have this wire which runs from this ground. This is a separate ground from the other side of the this ground here runs around to this ground. And then we have from this ground here, from this power supply, runs around to this ground. So they're trying to tie the power supplies together into the central point. And we have 2 ground loops here. We got 2 ground loops on, or more than 2 ground loops on the speaker terminals. So I think I'm just going to rip all this all out and redo it and do it properly. I'm going to treat these as isolated supplies, and I'm going to treat the right and left channels grounds, dedicate those to the isolated supplies, and then we're going to tie one ground wire between this star ground and this star ground, and we're going to break all these loops. And I think I'm going to do that. I don't understand why they did this. It just doesn't make sense. I was reading in the service manual this morning, and yeah, it's crazy. all the grounds they have. I don't know if they had a problem when they were doing development. Maybe they had a problem, but we're going to see. I'm going to fix it, or I'm going to change it. I'm not calling it a fix yet, but I'm going to change it, and we're going to see how we can make this a little better. Mostly concerned about power ground, keeping power ground separate from the signal grounds, and keeping power grounds low impedance, and keep them connected so that there's no loops in the power circuits. So let me get started with that. Another thing that's going on here is this is all 20 gauge wiring. I'm going to replace some of this wiring, especially the ones from from the output of the amplifier to the circuit breaker, from the circuit breaker to the front switch, from the front switch back is all 20 gauge. But I think I'm going to replace some of these runs with maybe upsize the wiring, and we'll see if that makes any improvements. I've done it before in other receivers, and it seems to help with sound quality. Another thing that Bob Cordell talked about in his book is distortion from all of the internal resistances of the amplifier. You have switching, relays, fuses, anything that's in the path of power or signal that can get in the way with its resistance can cause a distortion. And I think like I said, I'm going to replace some of these wires that snake through the bottom and back up again. We're going to shorten them up, and we're going to make them more direct, and we're going to make a heavier gauge out of the wire, and fix up that. We're going to make some improvements to this thing for sure. Okay, I made some big changes. Big changes are on the horizon. I'm going to do things my way now. So, got rid of a bunch of grounds that were running all over the place, that were just interfering with each other, creating loops. Let me see here, I'm going to collect up some wires. It's not all of them yet, it's still coming. All these wires here were grounds that I yanked out. And I also yanked out these two. These are speaker wire from the amplifier to the speaker switch. They're probably twice as long as what they need to be. So these are 20 gauge. I yanked them out and replaced them with 18 gauge. But that's not the big story here. The big story here is the grounds. So each set of speakers has their own independent ground now. So for the right channel for system A and the right channel system B are tied together, and that ground goes to the power supply for the right channel. Same goes for left. Ground for left is tied to the left power supply. And that makes sense because you don't want current flowing any other place other than directly to the power supply from the speakers. And then I eliminated the loops that ran from this starter ground to this ground. I eliminated them and just got rid of both of them and added one to bridge the two. So this isn't a loop anymore. This is just a direct connection from this ground to this ground. And then from here it spreads out. This goes to this, which is a power supply for the tuner. It needs a ground reference. Okay, so that's got its own ground. And then this is a tuner ground. So that runs around and comes out here. Tuner ground. And then this ground runs to chassis. So it's kind of spread out from there. There's no loops. Eliminate all the loops. I left the center tap of the transformer here. But what I did is I increased the copper, or reduced the resistance of this trace that runs to this capacitor. This is the grounds for these two capacitors. This is the ground for these two capacitors. So what I did is I beefed up the connection between the transformer center tap to these two banks of capacitors, getting rid of a lot of impedance and resistance. I don't know. They had another ground coming off of this They had another ground coming off the capacitor ground. Let's say this is 0 point for the capacitors. They had one running off to the side here, and this is where the speaker ground was taken from, but it wasn't properly executed. It was connected to each other. When it got to the connectors, they were all shorted out and they're all connected together, which wasn't right. So those grounds are independent. Now, bypassing. I'm a big fan of bypassing power supplies for power amplifiers. You can do it one of two ways. You can add bypass caps over here on your electrolytics, but that's really not going to do you any good because you have all this impedance through all these traces. It's best if you can put your bypass capacitor directly on the power for your output transistors, and in this case it's collector to collector. So there's a 1 microfarad cap here, film cap, low ESR, low impedance film cap between positive B plus and negative B plus, and that's about 75 volts there, and this is a 100 volt cap, so that should be fine. And did that on both channels. That's because you want any currents to circulate locally. You don't want currents to come back and get bypassed here and then flow back, because it's more efficient if you have the current local, the bypass current, instead of having it go through all this copper and back to the main filter caps. That's the purpose of adding local bypass, is to get it local and reduce those long flows of current. Now, is that going to make any difference? I don't know. You guys argue it out in the comment section. I believe it helps. I'm a big believer of increasing wire size from 20 gauge to 8. This is a 16 gauge here, 16 gauge here. This is all 16 gauge now. And getting rid of that 20 gauge they had wiring all over, all that spaghetti wiring. So I think it's going to make a nice addition, nice improvement for this amplifier. Hopefully it makes the sound better and more dynamic. And Harman Kardon always boasted about having high output currents for their amplifiers, but then they had it wired that way. It was kind of a joke. I've seen it on a lot of their older stuff too. They didn't really pay much attention to the wiring. The wiring for, let me flip this over. Wiring for the speaker outputs comes directly from the circuit breaker down and across to the switch, and then it transverses through the old wiring back to the back panel to the speaker connectors through this from the switch. I didn't bother changing this wiring. I'm just going to leave it alone. But this reduces some impedance here alone. Just getting rid of probably half the length, and I upsized the wiring to 18 gauge. So that's going to help. Okay, I believe we're at the point where I can power this up and do our initial test. Test for DC offset, test for bias. So let's get this underway. This is shut off. Let's plug it in and let's go for it. Went up to about 60 watts. Went down to about 14. Now it came back up to 20. Oh, sorry, you can't see that. Yeah. So normal power up. I have no speakers connected. We're at 21 watts and climbing. Let's get a measurement on DC offset. So, hope you can see this too. I'll put this here. Need a bigger bench. Can you see that? So we got 57 millivolts on that channel. 75 millivolts on that channel. So it's not bad. It's doing okay. We can zero that. We're at 23 watts right now and climbing. Let me do a quick measurement on the bias current across the emitter resistors. Let's see how this looks. This was the channel that blew up. And we got 18 millivolts. This was the good channel. That's 16 millivolts. All right. So what I'm going to do is I'm going to go zero the DC balance, set the bias, and then we'll come back. We'll do our power tests and distortion tests and whatever. I have a good feeling about this. Okay, still powered on. It's kind of stabilized around 26 watts consumption. So we're measuring across both emitter resistors. I got my leads on both emitter resistors here, and the trim pot is right here. So these are open frame trim pots, and I typically treat them with the green juice, right, the F100, and I don't replace a pot unless it's defective, but these are usually you just treat them and then you go like this and just work it back and forth, and cleans up the track from sitting in one position for so many decades. It sometimes gets flaky right around where it should be. So now I have that. We need to set this to 33, and oh, look at that, we're at 33 already. So I'll just leave that alone. We'll go up to the next set of emitter resistors, and we'll set up the other channel. Okay. So what do we got? We got 20 millivolts, and we'll just go, well, tweak up this pot. I already treated it, so I just need to work it. You can't see. Give it a good workout with the Deoxit F100. It cleans up that track pretty good. Alright. All we need to do now is set this. Wrong way. Alright, leave it there. Now we should be set. Power consumption is close to 30 watts. And we are ready to do testing. Alright, now that we have our initial adjustments, let's go in and do a power test. I want to see what this is good for. I'll put this here. I don't know if you can read this. Okay, we are live. The load's connected. Let's turn it up. There's clipping on the bottom way before the top one. Let's clip on the top first, and then we'll take a power measurement. Right there, I think. Okay, so what do we got? 17.44 volts RMS into 8 ohms. Let's check the other channel. I don't know why there's a difference between the two channels. So let's go up. Clipping's there. Let's back it off. Seems like we have right there, I think, 17.44. Look at that. The same. So one channel's an overachiever. So let's leave this for 10 minutes. We'll see how our amplifier does. What are we consuming? 134 watts input. Let this go for a while. Okay, we're coming up to 10-minute mark, but typically these amplifiers and receivers don't do well on the endurance test because, in my opinion, the heat sinking is not adequate. Right now I'm reading 57, 58, 59, 60. There's peak of 60, and I believe it because I can't keep my hand on this heat sink. It is over 60 degrees, but it's holding up. I'll reduce power, and then we'll do some tests on square waves. There's a nice looking square wave, 1 kilohertz, and we're at reduced power, 6.8 volts. Let's take it down to 1 watt. I'll take it down closer to here's 3.5 volts RMS. Alright, 1 kilohertz. Let's see how it looks on the low end. Hertz. Looking pretty good for 100 hertz. 50 hertz. You see the left channel is having a little difficulty. The right channel is holding up really well. On the low frequency end of the square wave, you want to look for tilt on the tops and bottoms. The more tilt you have, the more attenuation you'll have on the lower frequencies. It's 40 hertz, 30, 20. So I'm wondering what's going on here. This is the bass control. Bass control seems okay. I'm wondering if I have maybe a bum cap. This has been recapped though. Let's go look at the top end of the band here. That actually ain't bad because it's holding up pretty good. Not much difference between the channels. Let's go up. One kilohertz again. 2, 3, 4, 5. Looking very good at 5. 6, 7, 8, 9, 10. Still looking good at 10. 15 kilohertz. 20 kilohertz. $40 kilohertz. Use it right about here. 65 kilohertz, 68 kilohertz. It's doing really well. Oh, I'm pleased with this amp. Okay, so what to do now? I still waiting for the adhesive to dry on the front face plate, and then I'll put that back together. And I still need to put the light bar assembly back in, and then I can wrap this up. I think all my cleaning's done, all my adjustments. Let's try the tuner out. Alright, we're on AM.
The marshmallows fall. Exactly.
And I already see a problem here.
We like it. Say I could hold one in my...
This function switch.
Having a late spring where the snow is no longer nice and fluffy, it much rather...
This input switch is quite dirty and it's flaky. And that's one I didn't clean. I cleaned the tape monitor switch, but not this one. And I have to remove this now and clean this one. Okay. Let me see. I do have my stereo lamp hooked up. Let's get a little bit of an antenna happening. Let's connect it here, just for the... I'm getting any stereo. Maybe I got that backwards. Hang on. Might have put the LED on backwards.
love to talk to.
Edmonton's perfect music mix. Mix 1079.
You're beautiful.
I wish I never had.
Okay, so we have some work to do in the tuner. The FM's not kicking on, and I think that might be just an adjustment. I'm not sure, but it is working. I still need to remove this switch. I'll do that next. Take that out, clean the switch contacts because it is quite dirty. Oh, there's our stereo. It was on the wrong input selection. It's actually working pretty good. Yeah, I'm getting full signal. Sounds good. I'm pleased. Alright, switches out. And I pulled back the crimps. Let's see if we can get this open. Have a look inside. See how bad it is. Oh yeah, that'll need cleaning. Let me polish this up and then I'll give it a clean in the ultrasonic and then I'll bring it back and I'll show you what it looks like. Okay, here it is. You can see it's looking a lot better. This is what needs to happen before you have a good functioning switch again. Actually, I didn't clean very well inside there, but it's better than what it was. And so that's just silver polish on a Q-tip. Polish it until it's clean like that, and then dump it in the ultrasonic cleaner, clean off the polish, the residues, and then dry it with compressed air. And this is what we get. Now you got to be very careful with these pins because for whatever reason, well, they do it at the factory. They bend the pin over when they populate the board with the switch. They fold over some pins to hold it in place so it doesn't pop out. And you got to straighten these pins to get it out of the board. And in doing so, they're very fragile now because they can only take one flex and then they break. Even the act of unfolding the pin, see, here's one. Even the act of unfolding the pin can snap it off. So you got to be very careful. Okay, this can go back together. So let's just assemble this again. Come on. I should have done this from the start. I don't know why I didn't. I did the tape monitor switch, and the tape monitor switch was in worse condition than this one. But this one I wanted to kind of wait to see, and I should have just took it out and did it anyways, regardless. Okay, we got some lint and fuzz there. All right, 4 of those are on. Now we treat it, and for treating it I use this stuff. And it's very smooth. That's a lot. Why is this? That's way too much. But we'll spread it around. Okay. Alright, now we can put it back together. This has one orientation only, so we have wide space here, short space here. So we got to turn this around. So it goes like this. Let's see here. This switch is set up to the end. Let's set this one to the end. This is the important part, because when you put this together, you don't want to be crushing these things. If you crush these things, game over. You might as well start looking for a new switch. So you make sure they line up just so, and very carefully push it in place. Don't force anything. See, I think I got it the first try, which is unusual. Some of these things. There we go. I think I got it. Not quite. There we go. Push it home. Test it out. Alright, I'll crimp these back and then I'll solder it into the circuit. So I just went through and did the frequency response and the distortion test for both channels. I do them at 1 watt and then I do them at close to full power. Well, this one I did 20 watts, probably half power, and I'm pleased with the results. We're down around 0.015%, somewhere around there. And then it even drops lower on the 20 watt test, 007 and 0038%. Very low numbers. Now I was looking online to see what the specs were and I couldn't find anything. Even in the owner's manual there was nothing. But then I found this. This is from Germany and they actually publish specs in Germany. Seems like they're trying to hide the specs in North America. But this is our distortion figure here, is 0.5%. We're doing way better than 0.5%, many magnitudes better. So I don't know why they would rate their receiver at 0.5% THD. That's odd. And this is, interestingly enough, it's rated at 2 channels at 28 watts at 8 ohms. And I measured, what did I measure? I measured close to 38 or 39 watts. So yeah, it's doing well, very well. I do have a problem though. The problem is I have no power lamp. The LED is out. Either the LED's out or it's not getting any power. So let me try and see if I can measure any voltage across that LED. Let's see what we can get here. You can't read that, can you? Okay, let's see if I can get in here and get a reading. This has kind of got mains voltage here too, so I gotta be careful. Pull some of these wires out of the way. If you see a big spark and flash, call 911. Okay, here we go. Can't get in here. There's no room. Okay, maybe I got it that time. Not seeing anything here. Let me check back here. It's almost like we, oh, hang on, I got 5.7 volts there. So that LED's open, or the wiring's broke. And I can't measure back here. Let's see if I can get 5.7 volts here. Yes, we do. Okay, so that LED is dead probably. Probably what I got to do is remove this bottom plate again. It's kind of difficult. There's a couple screws, one here, and then you got to remove the nuts for 3 of the knobs. Remove the bottom plastic. This LED is probably dead, so I'll have to find another one and replace it. Here's a look at the parts that went into it. So originally we started off with 4 dead transistors and 1 dead resistor. So that was, I never really did figure out what caused this damage or what caused it to grenade itself. I did find a cracked solder joint, but I don't think that was the cause. I happen to think maybe one of these 2 transistors just failed from heat fatigue, because they are cooked looking. They're very dark. They used to be black, but now they're brown. You can't really see that. If I had it, let me dig out a comparison one and I'll show you. Okay, I found some TO92Ls. So look at the difference here. I don't know if you can see this. These are brand new, and this one's cooked. And you see how it's got a different shade to it? Like the black is no longer black. They turn brown when they get overheated, and that's from hundreds and thousands of hours of being turned on, and you know, all that heat, it just cooks the epoxy and turns it a different color. And you can see this difference in color. I think you can see that. And I think they just failed from fatigue mostly, so I don't know, I could be wrong. I replaced plastic screw. I always replace these plastic screws. This one was on the voltage regulator for the tuner power supply. I don't know why they put plastic screw. They could have just put a regular screw with an insulator. But these, over time, they crack and break, so I just get rid of them. And then there were a couple of dead caps in here. Where are they? They had green legs. This one here, I think. Nope. Dig through it. I should have dug through it before I turned the camera on. But there was a couple of dead ones in here. And the darker blue ones are the Matsushita. The lighter blue are the TK caps. They're all down in value and high ESR, so just replace them. And the 4 filter caps, they were weak as well, so they all got changed out. So that's all there was. Alright, well there it is. The power switch, or the power lamp, was working. It was just wired backwards. For whatever reason, I read in the service manual, I got that backwards, so that was my fault. But everything else is working. I did not do anything with the tuner. I think it's fine. I'm just going to leave it alone. But I'm going to enjoy listening to this one. This is a nice one. And it really turned out nice condition too. It's got some nice, it's really cleaned up really nice. So anyways, that's it for this one. Thanks for watching, and we'll see you in the next one. Take care.